HVAC 360, episode number 3, Daikin VRF Systems. Today we're going to listen to an interview I did on the AHR 2010 Expo floor in Orlando, Florida, where I got a chance to catch up with Brian Jialek of Daikin Air Conditioning Systems, talk a little bit about their Variable Refrigerant Flow Systems, or VRF for short. So without further ado, let's get into the interview. All right, we're standing here talking to Brian Jialek of Daikin, and we're talking to him a little bit about the variable refrigerant systems, the VRF systems, that you could possibly specify for your lead projects or your new buildings. Mm-hmm. So, Brian, could you tell us a little bit about the different varieties of variable refrigerant, or maybe step back, talk about when it was first introduced, how old is this technology, and...
This technology is produced and actually pioneered by Daikin back in the 1980s. It was tried with many other companies for years, all the way back to the 50s, but we pioneered some of the control functions in the 80s. Starting in 1984, 1988, we came out with VRV. So it was the first introduction of a variable refrigerant volume system that you could actually control properly. So the introduction of VRV gives you the advance of variable refrigerant volume, but you also have some advanced controls to help you have the advancement of individual zoning. So each individual zone has its own control with an electronic expansion valve, and the variable speed comes from the compressor. So the compressor will go from typically around 52 hertz all the way up to around 210 hertz.
Okay. Now what sort of applications were they first introduced into? I mean, were we talking...
Most of this was focused on commercial applications for Japanese market. So you're talking about mostly high-density areas, multi-story situations where you couldn't fit in a chiller application, pipework wouldn't fit, extensive ductwork would not fit in. So it was needed that they needed to have individual control, easy to install, flexible installation, kind of a modular arrangement.
Right.
So that's the original concept.
Okay. So when we talk about variable refrigerant, what are the kind of the different styles that you can get? Okay.
We've got going from single phase, we've got a single phase application for VRV, same technology, just with a single phase outdoor unit, can be used for a high-end residential situation, all the way to light commercial. Then we go into a three-phase situation for the outdoor unit, same architecture, in other words, ducted or non-ducted, ductless indoor units, and you can go from ranging from just a few indoor units up to 10, 12, 18 indoor units, depending on the tonnage. You're only capacity restricted, so you're not restricted by the number of indoor units, you're restricted on the tonnage and capacity that you're serving on the indoors. But this allows you some diversification, so if you've got a building that's not all 100% at the same time, you can use the load wherever in the space that you need, have actually more tonnage indoors than you have outdoors.
So you're talking about load shedding from a space that's hot to a space that's cold.
Correct, absolutely. So we're assuming that you have some diversity in the space. You don't have 100% in the whole space at one time. You can use that refrigerant to flow to the areas that need cooling or heating and move to other areas that don't. So as the sun goes from east to west, you can move the load from east to west. Or you can actually have an option with heat recovery, which you can have simultaneous heating and cooling at the same time. So heat pump is the base unit. So all the indoor units are heating or cooling at the same time. Or you can have heat recovery, which is just an added option. So you can have heating in one area, cooling in another. So you're just moving the heat within the space. That's all you're doing, instead of pushing it to the outdoor unit.
Okay. Now, as far as the different things that a designer should keep in mind when they're picking a variable refrigerant system,
right?
I guess the first thing is the difference between just a heat pump and the energy recovery system. They should know kind of what their loads are in the building.
Exactly.
If they need simultaneous heating and cooling, then they should stick with a heat pump.
I would, in a lot of cases, people typically jump right on board with heat recovery because you can do simultaneous heating and cooling, but that's not always needed within a building. So you could diversify with heat pumps within a building, zone it out, have a system that's on the east side, a system on the west side, and you can go strictly with heat pump. It's not a problem. So you could have heating in the morning on one side, cooling on the other side of the building. But if you use the heat recovery, it does allow you to have individual offices with individual control of heating and cooling at the same time.
Okay, a little bit more deluxe system.
Absolutely.
But if you can zone it correctly, the cheaper solution would be the heat pump.
Correct.
Now, what sort of premium, talking percentage-wise?
Typically around a 30% premium for heat recovery on most cases. It might be a little more depending on what style of indoor units that you select. Ducted is a little bit cheaper than some cases of individual units for each office. Mm-hmm. So you might duct 2 offices together, have that controlled off one controller, or you can have an individual control. Just cost more if you have more indoor units.
Okay. Now, I guess getting back to the designer, when they're selecting these units, obviously they've done their load calc. And I guess what's the next step once they know what the load is of the building?
The next step is probably select the indoor units. What style? Meaning, do you want a ductless, in other words, a wall mount, or a ceiling suspended, or a cassette? Or do you want a ducted variety where you can duct into multiple spaces at the same time? Obviously, if you can duct it into more spaces at one time, you save money with the indoor units cost. The next thing is you'll select, through our program, it's called VRF Express, take your indoor unit size with your heat loads, and then plug this all into a very simple program that's just drag and drop, and it will select your outdoor unit sizing. You can also even select your line length, and it'll derate the outdoor unit sizing for that selection with your control conditions. So whatever your block load is, certainly that's taken in, but this will actually take into account for your conditions for your particular area, your bin data, weather data.
So the software that you use, that's something that you give to the engineer free?
Absolutely.
And they can just, I guess, is there any sort of instruction tutorial? Is that pretty much
Absolutely.
included?
We have online courses, webinars for this program. It is a free program that we hand out, and we'll train people through a webcast webinar, and that happens once a month. And we can also do it ad hoc. It's a very simple arrangement to do a class. If we've got enough people, we'll just do a pickup class and do that. But typically it's scheduled once a month on a regular schedule.
Okay. Now, as far as ducting the above-the-ceiling units, the fans, is there any problem as far as like duct length is concerned? Is it pretty much standard along the lines of like a fan-powered box or whether it be a parallel or series?
It is a relatively low static system. So in most cases, the ducted applications are going to be 0.6 or less. And most applications, they'll really be in the range of about 0.2. So you're restricted on your total length that you're going to do with ductwork off the ducted units. But the idea is you're using the distance to the space on piping, not ductwork. So the idea is you're not losing efficiency with doing a long duct run. You just put it into your length of your copper work to the indoor unit and then drop it into the space. Okay. So typically your duct runs are less than 20 feet most of the time.
Okay, excellent. Now when we talk about placement of the units, what should engineers be cognizant of when they place? I guess it's not so much a concern with a cassette unit where it fits in the ceiling, or a wall hung where you can have access to it.
Right.
But when you're putting it above the ceiling, what areas are you going to need access to for these units?
Typically, the access is going to be about a 24 by 24 access to the bottom of the unit, so you can get to the controls, so you can get to the wiring. In other words, a control board as well, and that's all you really need access to. In most cases, it's built for a high-density situation, so you could have a ceiling height that's typically 24 inches or less and be able to fit a ducted product in, have an access space in a grid, like 2x2 drop-in tiles. 2x2 space is plenty of space to get up and service the unit itself. But in most applications, once the unit's commissioned, there's very little things that you have to get up to unless you have a failure of some sort along the way.
Right. Now, so everything is accessed from the bottom. Am I understanding that?
That's correct.
Okay. Now, as far as the controls of these units, now we've got them in the space, we've got the piping laid out, and at least from my understanding, the piping's probably the trickiest part to that. What do they need to focus on when they talk about the controls of these units.
That's a really good question. Let me tell you why. In a lot of applications with some other manufacturers, there's a lot of labor-intensive commissioning that's involved. Ours are auto-addressing. In other words, when the unit is started up, the outdoor unit will find each indoor unit, auto-address it, and then go through a check procedure. It's very straightforward and very intuitive. The other thing, too, with the controls is all of the controls to every one of the controllers and the control wires to each indoor unit is a 2-wire, simple 16 to 18 gauge connection. So there's nothing complicated about the wiring. It's not even polarity sensitive. So you could actually swap the wires, the 2 wires. It doesn't care. It's just a simple DC signal that goes to each unit, talks back and forth with the outdoor unit.
Okay. Now, what are some of the different pieces, parts that when you're installing the piping, that tends to be something that is more complicated than usual when you're manifolding all these units together. What sort of things are between the unit and the outside condensing unit?
Very good question as well. Look at it as a linear pipework that goes straight down, kind of a connection that we have branched off at each section to each indoor unit is called a ref net, and we supply that with the kit when we sell the job. So it does come supplied with a piping Y, so you'll pipe off to one unit and continue down the network to the next indoor unit, and you'll have another branch, and so on as you go down the line. As you're doing the control wiring, you can run the control wiring at the same time, daisy chain each indoor unit, and then out to the outdoor unit. Very simple installation. Typically, it's done at the same time as the pipe work.
Okay, so you have basically one sort of like modulating valve box right when it splits off from that.
No valve boxing needed. All you'll have is a Y. It'll pipe off to each indoor unit, and the control goes inside the unit. Each indoor unit has an electronic expansion valve.
Okay.
So if it needs more refrigerant, just opens up that valve. If it doesn't, it'll close off. Otherwise, it'll just go on to the next indoor unit.
Now, is there a difference between the regular heat pump and the heat recovery?
Sure. Good question as well. The heat pump typically is a 3-pipe system. So you'll have 3 pipes total, and the heat pump is just 2 pipes. You have a liquid and a suction side. So the heat recovery side, you'll have 3 pipes. It'll be a liquid, suction, and a gas. So that third gas line is important for bringing some additional refrigerant from the outdoor unit to supply heat to other areas of the building, as well as take heat from one area of the building to move it to another area. So it's basically a transit of hot gas that's going through that system.
As far as the valving or the distribution goes, is there any more equipment that's in the piping?
The difference between heat pump and heat recovery is there's a box in between for controls of the third pipe arrangement. So that system is called a BS box, a branch selector box, and it does all the functions for you. But if you want to break it down to its simplest units, think of it as another 3-way valve in the system, like a heat pump. So you're just shuttling the valve and moving the heat to a different part of the space.
Now, is there one box that does this, or does each unit have its own?
You'll need that for one box for each zone that you have. So if you have one ducted unit for each zone, you'll need one BS box for each box that you have. So if you have, say, multiple indoor units on a zone, you'll have a BS box and then piped out to several indoor units. But that will be considered one zone to itself.
Now, as far as comparing the different manufacturers, one of the questions that I get a lot is that, the difference in the piping. This is a 2-pipe model or this is a 3-pipe model. On the heat pump side of it, when you're just dealing with all heating or all cooling,
sure,
is there much difference between the manufacturers?
It's very similar in the technology. Daikin pioneered a lot of this back in the 80s and 90s. We're actually going in past our 5th generation of VRV at this point. So it's very well proven equipment, but there is very similar appearances and technology that you have with our competitors in some areas with the heat pump. Now, it varies wildly once you get into the heat recovery side because every company has its own way of doing it. Some manufacturers use one centralized big box that controls all of that function for the heat recovery function, and then some use individual boxes like us. It just depends which brand you pick.
Okay, but again, the only reason that you'd need the heat recovery is if you had that need for a simultaneous heating and cooling.
That is correct.
Okay. that you're going to end up paying a premium for, obviously.
Absolutely, with any brand. With any brand, absolutely.
Exactly. Now, as far as the some of the issues that you've had, I mean, I guess, what are some of the lessons learned that you've seen when we talk about designing or installing these type of systems?
The North American market is a especially large ducted market. And in foreign markets, they're not as heavy into the ducted side. So it was kind of a shift of our mentality of going from full ducted system to using less ducted and more ductless type systems. So it was kind of a paradigm shift from the standpoint of how we're looking at how we're doing air conditioning. If you've got the fan and the coil within the space that you're cooling or heating, it's far more efficient. And you don't have to push air down a ductwork, obviously. But some guys want to use ducted applications for noise or installation of the building. It actually looks cleaner to them, and that's fine. But as we first started the launch in the United States, everybody looked at the wall-mounted unit, which was our best seller globally, and said, no, we're not going to put those on the wall. They're ugly. It's just, that doesn't make sense. We'll do the ducted. So we started out that way. Well, now our biggest seller is the wall-mounted version, 2-to-1 over ducted now. So that is one of the big lessons that we learned, was trying to change some of the thought process in the design side. It's not necessarily a beautiful, attractive thing on the wall. It's not an architectural feature, but it does a very good job, and it is very quiet.
Right. Engineers love it. Architects hate it.
Exactly.
So now, as far as another big concern, another big hurdle that I've heard and I've seen throughout the investigation of the variable refrigerant systems is the outside air. How do you what's your take? What's your opinion on the outside air?
It's becoming, of course, more and more of an issue to cover many different issues related to ASHRAE codes, ASHRAE standards, and especially the fresh air standards. Bringing in outdoor air is absolutely a primary consideration on the design side now with engineers. So we have either ducted units that you can introduce into the return side, have a mixing box. That's the simplest. Other units that are ductless, like the cassettes, have a mixing box that you can add to them as an accessory. So you can bring in outdoor air and induce it into the cassette. Thirdly, you can do a full 100% outdoor air makeup unit that is a full ducted unit. So it's like a giant ducted unit, bring in 100% outdoor air. It will temper it. It controls off the off-coil temperature. So it set it on conditioning and go. You'll never change it again, and it's a very simple introduction of outdoor air.
Now, are you talking, so you have a unit that's 100% outside air?
Absolutely.
And it can handle that extra latent load?
Absolutely. Absolutely.
And this is not like, a central unit that serves other units. This is actually something you'd have in an office or a classroom. This is a terminal kind of device. It
is a 100% outdoor air unit, and it can be ducted directly into the space, or you can duct it in the individual indoor units if you prefer. But it is filtered, tempered air that's coming into the space, and it will be coming in at a temperature that's set at commissioning, whatever your set point is.
Now, is it the size much different than the indoor unit, or is it substantially larger?
The outdoor air processing unit has to carry a large range of temperatures, so it has a very big coil inside of it. And to also achieve the performance that we need, it has to be a large coil. So yes, it's typically twice the size of a ducted unit that would be a similar tonnage.
Okay, and that comes in both depth and height? That's
correct. Okay. Depth and height.
Or width and height?
Yep. Depth, height, and width.
Yes. Okay. Overall?
Yep, overall.
Okay. Now, is that a new unit?
Yes, it's not new globally. It's been used globally for many years. It's new to the U.S. market. There were some hurdles that we needed to jump from the standpoint of introducing it and being able to make sure that it will be used and properly applied with heat recovery, because there's some people that want to take that energy that you're pulling out at the entrance of the outdoor air and then be able to shed it to different parts of the building. So we were on to make sure that the engineering side was nailed down before we launched the product, and we've got that squared away now.
Okay.
So it was a huge product overseas. We just want to make sure that everything was parallel with all the products we had already.
Sure. Now, one question I've seen as far as what kind of, if I'm ducting directly to the unit, what kind of air should I be ducting directly in? Should it be tempered? Should it be,
It depends on the application, of course, and what part of the country that you're in.
Sure.
South Florida is going to be very different, obviously, than British Columbia. So in most applications, what I'm going to try to do is achieve a neutral air that I'm ducting to those indoor units, maybe in the range of somewhere between high 30s to the 60s, maybe even higher. The ducted outdoor unit will take a range that's much higher than that.
Okay. Now, so if I were to ask you, in some of the engineering examples that I've seen actually designed, is that a lot of them have cooled the air, taken the outside air, cooled the air down to 55 degrees to get some of the moisture out of the air,
sure,
and then ended up heating it back up to 70 degrees.
Right.
Is that something that you typically see?
We typically don't want to do that because you're wasting energy and reheating the air.
Right.
So in most applications, long as we're not trying to use a target relative humidity, we'll actually use the coil at its best as a total load and then have it brought in as neutral air. We don't want to reheat the air. That's a waste of energy in a lot of applications because a lot of folks will overcool the air to try to squeeze as much moisture out and then reheat it, as you mentioned, but it's a waste of energy in most applications. VRV can vary the actual refrigerant flow, so you got better control of the refrigerant and the dew point that you've got on that coil.
Oh, okay. Excellent. All right, so what else haven't we talked about?
Several different things that we're launching in other areas, other markets. Cold weather applications, we got an ultra-low ambient system that's VRV based. So you have an additional cabinet that's on to the side of it that adds another loop of refrigerant flow, similar to a cascade sort of refrigerant flow, and that achieves a lower discharge temperature, a lower ambient temperature that you can mount these systems outdoors. So the low ambient situation, you can have the units mounted outdoors to as low as minus 13F. So it's a very good application. Areas that heat pumps typically don't travel into in most cases. So very low ambient situations. We have a water-cooled unit, which is just a version of the air-cooled system, but you can use it on a water-cooled loop if you prefer. So water-cooled version. We also have introduction of new unitary systems. So your standard vertical air handler unit, that you have a single outdoor unit at your house, ducted applications. So use that standard footprint of a vertical air handler unit, have a ducted application and an inverter-driven outdoor unit that we have with Daikin technology. So we're really excited with that on the residential side.
So, something for the homeowner to think about.
That's right. Compete in the unitary market as well.
Okay. Now, as far as refrigerant goes, these are all what?
All 410A.
410A.
Yeah, we didn't launch any R22 in the United States. Basically, we wanted to be certainly more eco-friendly moving down that path. And Daikin is also the only company in the world, air conditioning manufacturer, that does manufacturing of equipment, controls, and refrigerant. So we're always looking forward to the next refrigerant and the next cycle to be as far and closer to a greener solution as we can.
Now, as far as the volume of the refrigerant, one thing that I've had on the back of my mind is there a size, like a tonnage range, where beyond this tonnage you need to start thinking about another unit because there's too much refrigerant in the system? So should there be a leak, it could be an issue.
To cover all the ASHRAE standards for refrigerant concentrations, we have the unit sized in a way that you shouldn't have any troubles with those situations. And we also, during the design of the system, will show engineers that this is a consideration of the space of probably the smallest you want to design with a single indoor unit serving it. So you have well within the ASHRAE standards for refrigerant concentration. Now, in most applications, you'll never even see that as far as the amount of refrigerant. As the units have gotten bigger and bigger, actual refrigerant that are stored in the units have gone down. So we're trying to get even better as far as the refrigerant management side to help that design side.
Okay. Now, when the engineer is designing it, they have the software, they learned how to use it, they designed the system. Can they send a file to you to check it?
Absolutely. Typically, along the design side, they'll design the system, select the indoor units, select the outdoor units with the VRF Express, plug in whatever controls that they've liked, whether it's single controls or BACnet or a iTouch controller, which helps on the building management side. And then they could send the file to us. We can review it with them or the rep in whatever case it is, whichever is the selling point. In most cases, it'll go through a rep, maybe a distributor, and we'll review the file with them, and the rep or distributor will give it back to the actual engineer. So we want to have a rep or distributor in the process so they can help on the design side.
Right. Excellent. So when we talk about controls, we've talked quite a bit about how the units are controlled. Say you have a Johnson system or a Train system.
Absolutely.
How do you get the information back to that?
Okay. It's a very common question when you get into the larger systems that they want to have it tied into a building automation system. Whether it's Johnson or Train, or it doesn't really matter, really.
Right.
As long as it's either BACnet capable system or if it's a LawnWorks capable system, we can do it either flavor. It doesn't matter. We've got gateways so that you can get the communications back and forth and be able to control and see every set point and sensor reading within a VRV system. So it's all very applicable on either side, BACnet or LawnWorks.
Okay. All right. Well, I appreciate your time here, Brian. Again, we're here at the floor of the AHR Expo 2010 in Orlando, and talking with Brian Jialek of Daikin.
Great.
Thank you very much.
Thank you.
All right, and we're back. I'd like to take this opportunity to thank Brian Jialek for participating in a conversation with HVAC 360. If you have any comments, you can send them to matt@buildingx.co, or you can contact me on Twitter @buildingx. So if you like this episode, feel free to pass it along, or send a link, or even mention it in passing, and I'd appreciate it. So thanks again for listening. So until next time, remember to know what you build and share what you know.